Hi, my name is Marcus Kohler. I'm a developer advocate here at PubNub, and today I'm going to be showing you how to build a complete skill-based matchmaking system using PubNub's real-time technology. Matchmaking is one of those things that is crucial for multiplayer games, yet I feel like it's not talked about enough. Building out a complete matchmaking system can be challenging, from managing queues to pre-lobbies to real-time player updates and elo adjustments. That's why I created this SBMM engine GitHub repository, a powerful open source tool designed to simplify the process for developers, whether you're building an FPS or RPG or even a casual multiplayer game. This repo is a great resource to kickstart your development and learn best practices for real-time updates. Before diving into building our skill-based matchmaking system, let's take a quick look at the documentation to understand what tools we'll be using. For this tutorial, we'll be making use of the PubNub Chat SDK, which is available in multiple languages, including JavaScript, Unreal Engine, Unity, and more. This makes it easy to integrate real-time functionality into your game, no matter what platform you're on. For this tutorial, we'll be focusing on the Chat SDK. This SDK provides powerful abstractions to handle chat-related functionality like user metadata, channel management, and messaging. It's specifically designed for real-time applications like multiplayer games, where low latency and scalability are crucial. Feel free to make use of the JavaScript, Unity, or Unreal Engine SDKs as well. However, the PubNub Chat SDK provides powerful abstractions to make it easier to manage users, channels, and metadata updates. So for simplicity, I decided to stick with the Chat SDK for this tutorial. So now that I've introduced you to the documentation and tools I will be using, let me introduce you to the demo application we'll be working on today. This demo showcases a fully functional skill-based matchmaking system built with PubNub's Chat SDK, as mentioned before. And here's how everything kind of works. So the demo can be found under developers and demos. If we navigate here, we can see the skill-based matchmaking demo that we're going to open up. Start demo. There's a link to the GitHub repository there as well. However, essentially, this demo showcases players essentially joining a queue and being matched together based on their skill level and latency. Players are arranged in different skill buckets based on their elo or metadata that they have stored in something called PubNub app context. They are essentially available or in a game that is simulated, and essentially it shows players going from being not in a game or available to entering a pre-lobby where both players will have to confirm their match to entering, if both players confirm their match, to entering a game, and that game gets simulated to going back and being available again. So that's the simulation I have architected with using PubNub. And essentially, we're going to go through the code and see how I've set up all these different real-time updates that have to occur to essentially achieve this type of simulation. Now, navigating to the GitHub, this GitHub will give you all the requirements, setup requirements for the repo, and it will have the fully completed code that I will be going over in this tutorial. Essentially, it will explain the different products that I've used, such as PubNub App Context, and it will go through the general architecture that I have set up for this repository. Next, it will go over the folder structure and show you guys where everything is located and the prerequisites that I am currently running the project on. It will show you how to set up your PubNub keys that we're going to go over shortly in this tutorial, and how to clone the repository. So the first part of this tutorial is we're going to set up our key set. So we're going to log into the PubNub portal here. We're essentially going to set up a free key set in PubNub. So I'm just going to log into the account I want to set it up under. I'm going to click on apps. I would create a free app, create an app in the PubNub portal, but I already have one called tutorials here. So I'm just going to utilize that application. Under that application, I'm going to create a key set, and I'm going to name it SBM tutorial key set. I'm going to So after I've created my key set, I'm going to copy the publish subscribe key and secret key into my repository. These keys will give me access to the PubNub network. The publish key is specifically for publishing messages, subscribe key for subscribing to messages, and the secret key is for protecting your messages. So I'll go more into depth about each of the keys in a second here. But first, let's go and clone the repo. So to clone the repo, I'm going to log into GitHub and go and navigate to SBMM engine. Under code, I'm going to copy the HTTPS link. I will need to open up my terminal and navigate to a folder, the code, and then make a folder called temp just SBMM, and we're gonna git clone the repo into that folder. After you have opened up the repository, it's going to be a little bit overwhelming, but essentially what we have here is we have two things. We have a client side to the application, which is going to represent our dashboard or a web application that is showing us the simulation that is occurring. And we're going to have this source folder, which is going to have all of our server functionality embedded inside of it. For this demo, I've stripped away all the PubNub functionality so we can step through it one at a time, and I can explain it as we go. But first, let's get those keys inside of our repository. I have included these .env.example files. These files I am going to rename to just .env. And I'm going to do the same for the server. So .example, and I'm going to just rename this to .env. So let's navigate back to the published PubNub dashboard or PubNub portal and copy our publish and subscribe keys. After we've copied those key sets into our repository, we're going to have to actually set up our key set so it's able to run this repository. We're going to have to enable certain permissions on the key set to have access to certain features that PubNub has. So first is the stream controller. Make sure this is enabled. This allows you to subscribe to different channels and receive messages. Also, you can have a wildcard subscribe, which allows you to subscribe to multiple channels at once. Next is presence. We don't need this for this key set. Access manager. We do not need that, but I highly recommend you do enable access manager and look through the documentation for how to set that up. That's going to provide you with a lot of security with sending messages across PubNub. Next is message persistent. This allows you to access the history of your messages, but since skill-based matchmaking is a really real-time use case, we do not actually need message persistence on this key set. We're going to enable app context and then enable user metadata events and channel metadata events. This is going to allow us to stream user metadata events from the PubNub database, which is known as app context, and channel metadata events, which is going to be really important for this demo. We're going to select a region. I'm going to select the US East because that's the region that is closest to me, but feel free to select the region that's closest to you. And we are going to save this configuration. We are also going to enforce referential integrity for memberships. This essentially means that when a channel is deleted, all the memberships for that channel are also going to be deleted. A membership is when a user joins a channel, they will be assigned a membership, which is an object that represents a relationship that the user has to that channel. And this is going to make sure that all memberships are deleted when a channel is deleted. With our current architecture, we are going to be using channels a lot to set up game lobbies and pre-lobbies, and we are going to use memberships to represent the relationship that users have to that channel. So this is a very important field to check. So back to the code, we're going to start with this listener.ts file. This listener is going to be on the server side of our application and is going to listen for message events representing a user joining a queue. So if a user sends a message to a specific regional channel, it will join a queue in that region, and we will essentially process that queue on the server side. So going down here, we will need first to initialize our chat instance. So to initialize our chat instance, what we want to use is we first want to import our chat SDK, which is just PubNub chat. You can install all these packages by just doing npm I. I included them all in the package.json. So this should work after you do npm install. I'm going to put this at the top of my code. After we have installed the chat SDK from PubNub, we are going to run await chat.init to initialize our chat instance. We are going to pass in our publish key, and we're going to need to get that from our env file that we set up before. So let me pass in the publish key, subscribe key, and we are also going to pass in a user ID for which user this is. I called this user server, so I'm just going to pass in my server ID here. After we have initialized the chat, we actually need to get the region channel for our server. I have used one regional channel for this use case. However, in a production use case, you would probably want to use multiple different channels depending on the region that the client exists in. For me, this is going to be US East, and that is going to be represented by a string where I'm going to create the channel with. When I first initialized my server, I don't know if this regional channel does exist yet, so I'm going to put in some functionality to ensure that it exists. So I'm going to code this function. It's going to be called get or create channel. We'll put a try statement, catch, just in case. We'll console.log the error. To test it out, and this function will be used to create the channel. So we're going to do let channel equal to await chat dot get channel, and we're going to pass in the channel ID, and then we're going to make sure this function get channel returns either a channel or null if the channel does not exist. So we're going to make sure that if the channel does not exist, then we do channel await chat.create public conversation. This is going to create a channel that essentially any user can join. And we're going to pass in the channel ID to that. Now that we can make sure that the channel exists, we can return that channel. Back to our listener, we are able to call this function get or create channel, and we're able to pass in our chat instance and our channel ID, which is region channel ID. So there was an error with the region channel, but that's because I didn't await this call. And now everything should work. So region channel is either channel or undefined. Only if there is an error within this function. So after we have created the channel and we can make sure it exists, we are going to join onto the channel listening for messages for the matchmaking queue. We are going to strip the user ID and the content. The content doesn't so much matter for the for a user to join the matchmaking queue, it is essentially just that the message has been received. If the user ID is already in the matchmaking queue, we're not going to do anything. But if they are not, we are going to set the user ID into this map, which is going to represent our matchmaking queue. We are then going to notify our testing client, which is our web application, that these are the users currently in the matchmaking queue. So to do that, we will need to use our notify client function that I have set up. So we will retry, and I will we will need to make a message payload to send to our web application. The message is going to be joining, and the users currently in the queue, so matched users, is going to be the user IDs that we send in. After that, we can call our function, notify client, and we can send in a channel ID and a message payload. What the notify client function does is it gets a chat instance, makes sure that the channel is created. It parses the JSON that we're sending in to a string or a stringified JSON, and it does channel.sendText, which is going to send the message across the PubNub network. On the client side or the web application, we can subscribe to this to receive that message. After that has occurred, we are going to set an interval to constantly process this matchmaking queue to make sure that people are being matched at a good rate. For the matchmaking, we are using a use case that is 1v1. So we're going to just ensure that the matchmaking queue is greater than 2. And after that, we are going to notify our actual client now, not our web client, but the actual client that is trying to join the matchmaking queue, that they are currently being processed. This is really important because you want to know on the client side if your request has actually gone through to start the whole matchmaking process. You don't want your players waiting there for matchmaking when there was an error with the request or anything. So we're going to notify them that the request has been sent through and everything has run smoothly. So to do that, we're essentially going to use the same kind of concept. We are going to create a message payload. And we're going to call it message. It's going to be processing. And the matched users that are currently in the queue are also going to be sent across. So you can double check that your user ID is in those user IDs. And we can notify the client by using our function. They are going to be binded to their own personal channel on the client side, which is going to be represented by their user ID. So the user ID that we are sending it to is this user ID. Only them will be binded to this listener, or event listener on the client side, and we're going to send them a message payload that their event has went through. Next thing we will need to do is we'll need to grab the user information of the user or their metadata information from PubNub app context. The reason why we're doing this is because for the next file, which is called matcher, this is going to match people based on their metadata, so their elo rating or their latency. So we'll need to grab their information at this point within the code. Essentially, to grab the user from app context, we are going to use this function called chat.getUser. And we're going to pass in all the user IDs of the people within the matchmaking queue. These can be, if the user does not exist, it will be null. And if the user does exist, it will pass back a user object. So we will have to filter these users. So essentially, after we have added a filter onto this to make sure that the users are not null, all these user details, then we can ensure them they're actually of type user. Console.log their name just to make sure, but we don't need that right now. And essentially this is done for the listener. So the next part of this tutorial, I want to go over how we can visualize these users within app context from the PubNub portal. We went over a bunch of functionality over how to create a listener and get data from a user, but let's say you're under a situation where you're trying to grab data for a user and it's coming back undefined, or the user details are coming back undefined, or the user doesn't exist. I want to go over how we can ensure all these users exist while we're coding our product. Essentially, this is something called BizOps Workspace. It's a workspace allowing you to manage your users, your channels. First, we're going to go and select the key set that or the application that we have created. And we're going to select the key set. Under user management, we'll be able to see all the users that have been created. There will be a name, maybe an email. I have an avatar picture within my metadata. I will show you guys how to update these users as well that I have been using, because this doesn't just magically appear here, and these custom data fields that I have been using. So what server they are connected to, if they're searching, if they've been punished, what their latency is, if they're in a pre-lobby, if they're in a match, what their elo rating is, or like whatever metadata that you have for your game, you can store within this app context. This is what app context looks like visually. When things update within this dashboard, so if I go and update the name and I save it, I can actually streamline these updates right to my application by binding to the user. We finished up the listener, and this was our matchmaking queue. On the client side, we have this file called runner.ts, which is simulating a user. This user is initiated through this function in main.ts. I'm initiating a bunch of users through these user IDs, or I'm fetching the users. First, before my server runs, since it is just a simulation, I am setting all these custom metadata fields. So I am setting the elo, if they're punished, confirmed, if they're in a match, if they're in a pre-lobby, what server they're connected to, their latency, if they're searching for a match or not. And I'm using a very simple function. I'm just passing that JSON into the user object for that user, and I'm calling .update. This will essentially push all that metadata right into app context. And whenever I update this metadata, I'm also able to use a function called user stream updates, and I'm actually able to stream updates from this user. So for example, if you're in a pre-lobby and you're able to select a cool skin for your game, maybe every client needs to know about which skin you're selecting. So you can actually bind to the metadata of this user to see, oh, did they select skin A or skin B? And it could update in real time while you're in the pre-lobby, making sure that everyone can see your new skin that you bought in the game, or whatever the use case may be. Sometimes they have latency, and you can see people's latencies within the lobby for that specific server. And if you want to stream those latencies to 10 different people within that pre-lobby, then you can also use user.stream updates for those types of use cases. We went over a bunch of content today, from processing matchmaking requests, setting up a listener, updating player metadata within app context, visualizing that player metadata. I know we didn't have time to go over everything that was associated within this demo. However, in the meantime, feel free to check out the PubNub documentations in the GitHub to find out more.